Welcome to this channel for solutions of practice problems for actuarial exams. We'll look at problem for exam P on probability. You can find information about me at this site, smarturl.it/Jedi. You can email me at this address here, and it's the Polish version of my name that is used here. It's krzysia@krzysia.net. If you don't speak Polish, well, it's a bit harder, but if you go to my website, smarturl.it/Jedi, there should be a link there to email me. This is an exercise posted by the Society of Actuaries, and I'm giving you my solution to it. A survey of a group's viewing habits over the last year revealed the following information. 28% watched gymnastics, 29% watched baseball, 19% watched soccer, 14% watched gymnastics and baseball, 12% watched baseball and soccer, 10% watched gymnastics and soccer, 8% watched all three sports. Calculate the percentage of the group that watched none of the three sports during the last year. And these percentages here, by the way, are effectively interpreted as probabilities. So you will be working with basic probability theory when solving this. So the most important rule when working with basic probability is to label the events and then write out what we know. Let us label G to be watching gymnastics, the event of watching gymnastics, B, the event of watching baseball, F, the event of watching soccer, F for football, as the rest of the world calls it, because we use S for the entire probability space, so I don't want to use the same letter for two things. That doesn't make sense. And we are given that probability of G is 0.28, probability of B is 0.29, probability of F is 0.19, probability of G intersection B is 0.14, probability of B intersection F is 0.12, probability of G intersection F is 0.10, and probability of intersection of G and B and F is 0.08. And then we can actually see the whole picture of this by drawing diagram of it's a form of Venn diagram of showing all these events, and that's what I'm going to show you now. So this diagram here doesn't really have these probabilities that you see in there as exactly the probabilities given a moment ago. Instead, I have split each event into non-overlapping pieces. G has the piece that is around here, another one here, another one here, another one here, and this 0.08 in the middle, that's the intersection of all three of them. That's directly given. Then the intersection of G and B had a total of probability of 0.14, and because 0.08 is inside here, then the rest is 0.06. The intersection of G and F had a total probability of 0.10, and because 0.08 again is in the middle there, what is remaining is 0.02. The intersection of B and F had a total probability of 0.12, and because 0.08 is used up by this piece, the remaining part for that piece here is 0.04. And then from the total probability of G, we take out these three pieces, and what is left is 0.12 for the part over here only. And for B, that part that is not in F and not in G has a probability of 0.11, and for F, that probability that is not in B and not in G has a probability of 0.05. The question in the problem actually asks for the probability of being outside of all three of those oval areas of G, B, and F. And we can get that by taking 1 minus the sum of all the individual pieces that we split into non-overlapping pieces. So we can just add those individual probabilities and subtract the sum from 1, which is effectively what you see in this formula here. It's not directly done this way. It's instead done this way, that we take 1 and we take out of it every single probability that we see here. And what is left is 0.52, and that's the answer. We can also use this kind of a formal calculation. We're looking for the probability of the complement of the union of G and B and F, which is 1 minus the probability of the union. And then what is the formula for the probability of the union of three events is a sum of probabilities minus the probabilities of intersections of two plus the of two of them, which is three such probabilities, and minus the probability of intersection of all three of them. I'm sorry, it's plus if we take the sum, so plus, but it's a minus here because we're subtracting that, so we get minus the probabilities of individual events plus, because of minus, the probability of intersection of 2, and minus the probability of intersection of 3. And we just plug in the numbers that are actually given in this problem, and we get the same answer. Please remember that this is copyrighted material, and old problems from actuarial exams are copyrighted by the societies that offer the exam, in this case, Society of Actuaries. Good luck in your studies and on the test.